All right. Multiplying fractions by whole numbers today. What are some ways that we can think about multiplying fractions and whole numbers? Well, first of all, let me ask you this. Who can give me their age? Your age. What is your age, Cole? 10. So do you know that we can write the number 10 as a fraction? How would we write it as a fraction? Dathan? That's a decimal. I want it as a fraction. And that would actually, as a decimal, it would be 10.0. I want it as a fraction. What do you think, Darius? Well, if you are 10 tenths, that means you're 1. So that's not going to work. That's not going to work. Will? 10 1/100ths is the same thing as 1/10. That's 0.1. No, that's not going to work. How would we write the number 10 as a fraction? Caden? 10 over 1. Now, if someone asks you how old you are, do you ever say, I'm 10 over 1? No. But today, we're going to have to take whole numbers and we're going to have to make them into fractions. So this is how to do it. If you were 6 years old, as a fraction, you would write that 6 over 1. If you're 41, like me, you would write that 41 over 1. Okay? So that's the first thing we need to know. So our first question to get us started thinking about this is, we have a drink recipe, and it needs 3/4 of a cup of orange juice for every batch that we make. But we're going to make 8 batches. Okay? So how do we do this? How do we figure this out? Well, we could use repeated addition. We could take 3/4 and we could add them up 8 times, right? Okay, so if we all know how to add fractions, we would add up all of our 3's, and since we have a common denominator, we just leave our 4 alone. So that means we would have 24 over 4. What is 24 divided by 4? Remember, the bar means divide. Will? Not 0. 24 divided by 4. Brendan? Not 5. America? 24 divided by 4? You guys, come on now. I know it's Friday, but everybody should know 24 divided by 4. Aiden? 6. So what do we need for juice? We need 6 cups of juice. 24 divided by 4 is 6 cups. But there is a much quicker and easier way to find this answer. The reason we only added our numerators here is because in adding, we don't add up our denominator. We keep our denominator the constant. You told me how to simplify. 24 over 4 is an improper fraction. Luckily, this turned out to be an even number. 24 divided by 4 was 6. Okay, so here's another way to think about multiplication. We are going to take 3/4 and we're going to multiply it times 8. But how do I write 8 as a fraction? 8 ones. That's right, 8 ones. So here's one way to multiply these two fractions. We can multiply our numerators and then multiply our denominators. Piece of cake, right? There's a different strategy that works as well. Today, you get to decide what works for you. Let me show you this other strategy. It's called cross-checking. So we look at the numbers that are opposite each other. For example, the 1 and the 3. Is there a number I can divide both 1 and 3 by other than the number 1? Nope. Okay, now let's look at the other two. A 4 and an 8. Is there a number that I could divide both 4 and 8 by? What is it? 4. Or 2. We can't divide 4 by... There are no 8s in 4. No, that won't work. But the biggest number that goes into both of them is 4. How many 4s are in this number? How many 4s are in this number? Now I can multiply my tops. 3 times 2 is 6. I can multiply my bottoms. 1 times 1 is 1. And hey, I've got the answer. So either way is okay. I will tell you this. Today, you will probably notice that doing it this way, where you cross-check, is much, much faster. Once you're starting to deal with larger numbers, you'll probably notice that I can't do this in my head, so you'll have to find a spot off to the side. Well, who wants to take the time to do that, right? Okay, we're going to focus on these next ones together. So 1/7 of 14. Well, the word of, if you look back on my poster, of means to do what? To multiply. So anytime you see of, literally turn it into a multiply sign. Now, we have 14. Can we make that into a fraction? Okay. Now we can multiply our tops and we can multiply our bottoms, or we can cross-check. Which strategy do you want to try this time? Multiply. Okay. Multiply your tops. Multiply your bottoms. Which gives you 14 divided by 7. Remember, the bar means divide. What? 2. Okay? Looks good. Now, the next problem we're going to do, I'm not going to let you do it like this. We're going to try cross-checking. Okay. Oops, I'm going to use green. The word of, make it into a multiply sign. The number 14, make it into a fraction. Okay? Again, I'm not going to let you use the same strategy. Let's do something different. Let's start with the 3 and the 1. Can we do anything with that? Anytime you see a 1, there's nothing you can do. If I divide both of these by 1, they're going to end up being the exact same thing. So let's look at 7 and 14. What's the largest number I can divide both of those by? 7. How many 7s are in this number? How many 7s are in this number? Let's multiply our tops. Multiply our bottoms. 6 over 1 is the same thing as, there you go. Now, as we're doing these practice examples today, I want you to think to yourself, what's the strategy that works best for me? What am I quickest and most efficient at? Okay, again, another one together. Emma, first thing I need to do is, good work. Now, what strategy would you like to use? Okay, we can't cross-check the 1s, but we can cross-check the 25 and the 5. What's the biggest number that'll go into both? How many 5s are in this number? How many 5s are in this number? Okay, let's multiply our tops and our bottoms, Emma. Over, which it equals. Pretty simple, right? Now, I'm not going to lie. They've given you some easy ones to start with. They're going to get a little bit harder. Yes? Absolutely. In fact, well, my guess is that you're going to get good enough at this today that a lot of these you can do in your head. Okay? All right. Okay, this one's a little bit different. I notice something in this problem that I haven't seen in any others. Erin, what did you notice? Oh, okay, it has parentheses. So anytime you see parentheses, you know you have to do what? Okay, so in our heads, we can do 5, 6 minus 2, 6. Erin, what is it? 3, 6. So I'm going to rewrite this. 3/6 times 40. Okay? I'm going to make this into a fraction, right? Now, what strategy do you guys want to use? Cross-check. Nothing with the 3 and the 1. How about the 6 and the 40? What's the biggest number that'll go into both of those? This is a challenge problem. You won't have one this hard today, by the way. Dathan? No, okay, we have to divide, though. We're dividing a number by into both of those. A number, what's the biggest number that goes into both 6 and 20? Excuse me, 6 and 40. It can't be any bigger than a 6. 2, okay? How many 2s are in this number? Okay. How many 2s are in this number? Okay, let's multiply our tops. Let's multiply our bottoms, which gives you 60 divided by 2 is 30. It's just 30. Plain old 30. There's your answer. This was a tough one. They won't give you one quite this hard today. Kaden, did you have a question? Oh, that is totally my fault. Gosh, I'm so glad that you noticed that. I don't know what we were thinking here. You're right. This should have been 3. So 60 divided by 3 should have been, yeah, 20, not 30. My mistake. Sorry about that. Okay. I'm forgiven. All right. I would like you to grab your whiteboards. And let's do a few examples today. We're going to start out easy. On the first few, I would really like for you to write these out. Now, as you get better after a few of them, if you notice you can do them in your head, that's okay. One-eighth of 24. Everybody's working on their own. Cross-check or multiply, doesn't matter. Okay, Cole, help me out. Nobody erase because you guys are going to show me. You cross-checked? You didn't. There it is. In this particular problem, it's pretty fast to just multiply. It won't be as fast when we have larger numbers to deal with. Okay? All right, ready for the next one? I'm going to make this one very similar but harder. Very similar problem but harder. It's best if you guys can sit with those tilted so that everybody in your pod can't look at your answers. Now, as I look at this problem, I think to myself, there's no way I want to multiply because I can't do it in my head and I won't be able to divide in my head. So I'm going to have to do something up in here. I'm going to have to do something down in here. I don't want to waste all my time. Instead, I'm probably going to cross-check this one because it's so much quicker to do so. But again, it's up to you. When you cross-checked, what did you get, Sarah? Can you do anything with the 7 and the 1? No. Okay, what's the biggest number that'll go into both 8 and 24? Sarah, can you tell me what's the biggest number that goes into both 8 and 24? How many 8s are in this number? How many 8s are in this number? Now I can multiply my tops and my bottoms and get 21 over 1, which is the same thing as just 21. Okay, today's secret password is chocolate. Show me what you got. Very good. All right, let's move on. Let's see if we can do the next one in our heads. You can write it down, but let's just see if you can do it in your head. Here you go. Just look at it and see if you think you can do it in your head. If you can't, that's fine. Work it out. Those of you who know your math facts are going to be able to handle this lesson quite quickly and easily. Will? Yeah. Which is what? You're right, it is 56/7, but that's not the final answer. I wouldn't be able... What? Oh. And then divided by that, 8. Just 8. 56 divided by 7 is just plain old 8. Good job. Okay, let's try another one. I've got 30 seconds. I want to try to get this one in. Here we go. Here's an example of one that you probably will want to cross-check so you don't have to do the multiplying and the dividing in your head. The biggest number that goes into both is 7. There's 1 7 here, 3 sevens here.